Moment of inertia of a rigid body depends on mass of the body and distribution of mass about given axis of rotation. Whenever we are changing the position of axis of rotation, at that time the moment of inertia change. It is because of change in the distribution of mass. If moment of inertia about one of the axes is known to us, we are able to determine moment of inertia about another axis by using either the principle of parallel axis or principle of perpendicular axes. In this video lecture, we are going to study the principle of perpendicular axes and we will see how it can be used to determine the moment of inertia about a different axis. To study the principle of perpendicular axes, one thing that is to be noted is that principle of perpendicular axes is applicable only for the two-dimensional laminar bodies. For the sake of convenience, we will consider this book as a two-dimensional laminar body because it has length, it has breadth, it has thickness, but thickness as compared to length and breadth is small, too small, therefore it can be neglected. Therefore we will consider this as a laminar body. Let this book is in XY plane. For the sake of convenience, we will consider this as x-axis, this one as y-axis, and obviously the intersection of x-axis and y-axis will be the corner and the axis perpendicular to plane of lamina and passes through the origin is the z-axis. Therefore, this will be the z-axis. According to principle of perpendicular axes, moment of inertia of a plane lamina about an axis perpendicular to its plane is equal to sum of its moments of inertia about two mutually perpendicular axes in the plane of lamina intersecting at a point where perpendicular axis cuts the lamina. How it is so? It can be proved by considering a plane lamina in XY plane. This is a plane lamina in XY plane. This is z-axis perpendicular to the plane of lamina intersecting at origin where x and y axis cuts the lamina, intersect the lamina. X and y, how they are? X and y are in the plane of lamina. Z is perpendicular to plane of lamina. X and y meets at origin. Z cuts at origin. Moment of inertia of this plane lamina about an axis perpendicular to its plane, that is Iz, is equal to sum of its moment of inertia about two perpendicular axes in the plane of lamina intersecting at a point where perpendicular axis cuts the lamina. This is the statement of principle of or theorem of perpendicular axes. We will prove this. For that, let us consider there is a mass element dm situated at point P. Coordinates of P are x and y. The moment of inertia of this mass element about x-axis is product of mass and square of distance. Here, distance of P from x-axis, if it is y, it should be y. Therefore, moment of inertia of element dm, that is product of mass and square of distance, y square dm. Moment of inertia of a element dm about x-axis is y square dm, and moment of inertia of this plane lamina about x-axis is integration y square dm. In a similar manner, moment of inertia of a plane lamina about axis coinciding with y-axis, product of mass dm and square of distance. If it is x, it should be also equal to x. Therefore, it is integration x square dm. Adding these two, we will get ix plus iy is equal to integration x square plus y square into dm is equal to x square plus y square is equal to r square. It is integration of r square dm. R square is distance of mass element dm from z axis. Therefore, it should be equal to iz. Therefore, ix plus iy is equal to iz. This is the mathematical equation of principle of perpendicular axis. How principle of perpendicular axis is helpful? We will demonstrate with the help of a disk. Let us consider it's a disk, a very thin disk. It's a two-dimensional plane. Let us consider these are two axes in the plane of the disk. I will keep this in a vertical plane. This is x-axis and this will be the y-axis. These two axes are perpendicular to each other. They intersect at origin and z-axis passes through origin. All the three are perpendicular to each other. This is the x-axis, this will be the y-axis, and this will be the z-axis, perpendicular to the plane of the disk. Moment of inertia of the disk about this z-axis is known to us. What this? This is Iz equal to, that is equal to mr square by 2, because this z-axis is perpendicular to the plane passing through center, and for a disk, axis perpendicular to the plane and passing through center is central transverse axis. For central transverse axis of a disk, moment of inertia is mr square by 2. X-axis and y-axis are in the plane of the disk passing through center of the disk. Therefore, one of the diameters coincides with x-axis and as well as y-axis. Distribution of mass of the disk about any of the diameter will be the same. Therefore, the moment of inertia about x-axis is equal to moment of inertia about y-axis is equal to moment of inertia about the diameter. Therefore, moment of inertia about z-axis is equal to moment of inertia about x-axis plus y-axis, moment of inertia about y-axis. It is mr square by 2 is equal to one of the diameter coincides with x-axis, other diameter coincides with y-axis. Distribution of mass about any diameter will be the same. Therefore, Ix is equal to Iy is equal to Id, and from this I am able to write here is that moment of inertia about any diameter is equal to mr square by 4. Thus, knowing the moment of inertia of a disk about a central transverse axis, we are able to find out, knowing the moment of inertia about a central transverse axis, we are able to find out the moment of inertia about the diameter using the principle or theorem of perpendicular axes. Thank you very much.